Question of the week from the Naked Scientists.
Hello and welcome to Question of the Week. This week we're answering a question sent in by listener Phil, who asks, what makes up the space when subatomic particles move to a different place in space? Is it a void? Good question, Phil. Alan on the forum chimes in with a good point. He says, yes, or at least from the point of view of the particle. The physics model that we use uses interaction cross-sections of different particles and media. The cross-section for neutrino to anything, for example, is so small that the neutrino's universe consists of almost entirely empty space. But if we look at an atomic structure, the electrons on the periphery are whizzing around in a sort of cloud. But they can't be all places at all times, even if they do travel at the speed of light. So what, if anything, makes up the empty space in their momentary absence? Well, regrettably, the answer is quantum physics. Fortunately, we have the University of Cambridge's Ben Alanak to talk us through it.
Well, there is something in apparently empty space, actually, because no space is completely empty. If you look at it at the smallest distance scales, quantum field theory tells you that every species of particle has a kind of quantum jelly, let's call it, associated with it, which fills the entire space. When there's a ripple in this jelly, there's a small, spatially small ripple. That's where we would measure a particle there. So if there's an electron jelly, for example, throughout all space, when there's a localized ripple in that electron jelly, that's where we would measure an electron. And every particle species has one of these. And if you have moving ripples, if the ripples move along the electron jelly, they will tend to excite ripples in the photon jelly. And so what we understand then is that moving electrons tend to produce particles of light, photons. This is a big old complicated theory, but what happens is when you look at the tiniest distance scales, all of these jellies actually are all wobbling about and being very unruly. So they're all sitting on the kind of background space and time.
You're saying that when there isn't, say, a subatomic particle filling a space, there is still this almost four-dimensional net, this quantum field that holds stuff together.
It's like the potential. You can just think of it as the potential for a particle to be there. And then when there's a ripple in it, then you've got a good probability of the particle being there.
Big thanks to Phil for the question and Ben Alanak for the answer. Next time, we're answering a question from listener David, who asks, can you extract DNA from fossils? Good question, and we'll be digging into that one next time. In the meantime, if you think you know the answer or have a question of your own, the email address is chris@nakedscientist.com or join us on the forums at nakedscientist.com/forum.
Question of the Week is part of the Naked Scientists podcast and supported by the Wellcome Trust and UK Fast. Look us up online at nakedscientists.com.